Alright, time for another DraftPhysics.com, debatephysics.com also. But, I stated, no one to debate. So this is part 2. I'll put 2 here. 2. Okay. Who knows how many parts it'll take. Anyway, Jim Al-Khalili. Something like that. Anyway, and about atoms mostly, but it's just lots of other stuff thrown in, so it's not really about atoms. Tiny little bit is about atoms. The rest is about all this wooey crap. So anyway, we're getting to some of the woo soon. But anyway, alright, so where I left off is somewhere around here. And so they're now going to reflect energy, okay? We don't know exactly what they got back. Off of a, atoms. So gold leaf, shoot radioactive particles at it and see what you get back. Helium nucleuses. Anyway, I think I've already explained it. They're big, but they're not as big as the big giant atoms. And you could hit a lot of different places, and they could scatter in lots of different directions. And to get a perfect reflection, or to get something like a reflection, probably requires the atom of gold to be moving towards you. So it has its own momentum towards. So the results make it look like the nucleus is smaller than it really is, I think. I don't know if they have any other experiments confirming this size thing, but I think they're wrong. I think you can deduce they're wrong because all kinds of energy bounces off pretty close to the surface of materials, and it wouldn't be able to bounce off the surface if electrons and nucleuses were so full of empty space. Anyway, continuing.
Alright, let's do this.
Deadpool and Wolverine.
Fuck. Jesus, I hate this shit. Commercials.
One afternoon in 1909, Geiger burst into Rutherford's office with some astonishing news. Very, very occasionally, an alpha particle would indeed ricochet back off the gold leaf.
Alright, just indicating why I think all this is just such made-up storytelling. If it's very, very occasionally, see, if it happened just once in 4 days, then you can understand him bursting into the office and saying, look, it happened once. We had it happened once. But you don't go 4 days with nothing and then all of a sudden one day with something. That sounds like bullshit.
Geiger calculated that only 1 in 8,000 alpha particles would do this. It's a tiny percentage, but Rutherford's mind reeled with the news.
Right, and from that 8,000 they project that it's 10,000 units of empty space per 1 unit of nucleus. And I'm going to argue that's a bullshit calculation because you had to hit just right on an atom moving toward. So the atoms are hot, they're moving in all kinds of directions. It has to be moving towards you and you hit it with the alpha particle. So it's not as small as it looks.
He would later say it was like firing a shell at a piece of tissue paper and have it bounce back at you.
Alright, so he can have whatever statements he wishes to make, but obviously it's not true. So this is the exaggeration of the mv squared maybe, or something else. But it's that's sort of a preposterous exaggeration. The gold atoms are still pretty big.
There and then, Rutherford knew he'd struck physics gold.
Pretty heavy.
Although it would take him over a year to fully understand why the alpha particles would do this, when he did, he would show humanity for the first time the inside of an atom. Now, people had barely got used to the idea that atoms existed.
So this isn't exactly showing anything, so again, it's just more exaggeration. But the idea that there was a nucleus was already in the mix, and he's just basically, this is sort of like the Einstein contribution of Brownian motion. It just kind of confirms where they're already heading.
Now,
I mean, I understand, they already knew about charge. They already knew about electrons moving from one object to another object, that you were moving electrons when you were moving charges. And obviously, the protons have to be somewhere. I mean, come on.
Rutherford knew that this minute world 1/10 of a millionth of a millimeter across, had its own internal structure. Within the atomic, there's a subatomic world.
Right, so that was already, like I said, everybody already knew that. You know, it's just defining the geometry.
And Ernest Rutherford believed he knew what it looked like. Rutherford realized that the bouncing alpha particle revealed an atom that was totally unexpected. It had no familiar analogy on Earth.
Yeah. It's just unexpected. What, you're supposed to expect something? So they called it the plum pudding model, but this is kind of funny because obviously this orbiting model isn't the plum pudding thing. So where did that come from? So this story doesn't seem completely consistent, or at least these other stories don't seem completely consistent, because there was supposed to be this modification by Bohr that added the solar system part. But in this account, Rutherford's responsible for the solar system.
So Rutherford looked for one in the heavens. He pictured the atom as a tiny solar system. Electrons, tiny...
So I don't know exactly why they did this part. So the idea is you have two charges, protons and electrons. And I just don't see why you would have to make it extraordinary like this with all this motion. Because motion's... I mean, you know, a physicist would know that orbits are complex and that a tiny perturbation in an orbit screws it all up, and you know the thing shoots out or it falls into the sun. So it's not a practical thing. And then you know that these atoms have to combine based on their electrons and protons, either the existence of an extra electron or the absence of an electron. And this model isn't going to do any of that. So I don't even, you know, to me it's such a bad representation when they played with magnets. They knew how magnets work. Why not use a magnetic model? All you need to do is have, you know, you have an electron here, an electron here, and you have a proton here. Well, you can understand that another proton could sit here because it's further away from the other proton and it's attracted to the two electrons, and it can just sit in that position. Perfectly reasonable.
Tiny particles of negative electricity orbit around a minute, positively charged object called the nucleus.
Alright, so it's positively charged, but that doesn't mean it's all positive and nothing else. So the trick is it's positive 2 to 1. Alright, it has twice as much positive as it has negative, so it's a half positive. But, you know, they made a mess out of that too.
Rutherford calculated that the nucleus was 10,000 times smaller than the atom itself.
So, again, and he's calculating that based on assumptions. So he's assuming that he could hit any part of the nucleus and he'd get this perfect reflection. That's probably a wrong assumption. He's assuming that the atom is stationary. You know, where our argument could be made that you can't get a reflection unless the heavier momentum is in the atom. So the atom had to have more momentum moving towards the helium nucleus. So in the experiment, when they're shooting the helium nucleus, this heavy atom needs to have more momentum if it's going to cause a reflection. Because if it has less momentum, then it's going to lose.
That's why only 1 in 8,000 alpha particles bounce back. They're the ones that hit the tiny nucleus by chance. The rest whiz by with...
It's always by chance, whatever that is. Shit. So, okay, but I'm just saying it's just perfectly logical for somebody to say, but that little atom is not stationary. That nucleus is not stationary. They know that it's jittering. It's doing all kinds of motion. And the key ingredient could be it has to jitter in the opposite direction to get a reflection. Perfectly reasonable. What do you call it? Speculation.
Without hitting anything. The first astonishing consequence of this idea is that Rutherford's atom is almost entirely empty space. That's why nearly all the alpha particles race through the gold atoms as if there's nothing there. There really is nothing there.
So let's understand that they're hitting things. It's just that if they're a helium nucleus against an electron, it's going to be much of a battle. So obviously the electron's going to lose. And they weren't looking for ionization or charge or any of those kinds of effects that this would have been causing. They were looking for one distinct thing, a pretty intense particle popping out. So they weren't measuring any of the other heating effects that were taking place.
Consider the bizarre implications of Rutherford's atom by imagining it on a bigger scale. If the nucleus were the size of a football, then the nearest electron will be in orbit half a mile away.
So does that seem realistic to you? Okay, it doesn't seem realistic to me. These charges do have to see each other, and it just, I don't buy it. So I'm just saying that for me personally, this isn't a viable story, that the electrons and protons could be that far away and especially have enough attractive force to orbit. That would be really preposterous. So I don't think so.
The rest of the atom will be completely empty space. Let me explain it another way. If you were to suck out all the empty space from every atom in my body, then I would shrink down to a size smaller than a grain of salt. Of course, I'd still weigh the same. And if you did the same thing to the entire human race...
All right, so the joke there is he just says, I would still weigh the same. No, you wouldn't, because the atomic, the weights you have for electrons and protons don't equal your weight. So clearly you've made some mistakes in gaining an accurate definition of the weight of electrons and protons, because they don't actually add up to your actual material weight.
Then all 6 billion of us would fit inside a single apple. The atom was unlike anything we had ever encountered before, and it would only get stranger and stranger.
School is back.
Oh, brother. It's too many of these commercials. I guess I'll have to download these in the future. All right, anyway, continuing.
Almost immediately, a problem surfaced, and it was a big one. According to the tried and trusted science of the time, the electrons should lose their energy, run out of speed, and spiral into the nucleus in less than a blink of an eye.
All right, so this has been an argument I've refuted before, but I mean, there's absolutely no reason to think that the electrons would do any of that stuff, like they somehow are losing energy by orbiting. I mean, there's just no reason to think so. And their fix doesn't fix anything. They just say there's some standard orbit where there's no friction, and there's no obligation for the electron to produce any electric field or whatever the hell. But it's always producing. It's always just reflecting the world that hits it. That's all it can do. And so, yes, I would argue that electrons would be dragged because they're moving into a field and they're going to hit it. All right? So they are going to end up slowing down. They won't stay in an orbit. But it's not for the reasons they say. The electron doesn't do any work. It doesn't excrete a force. It doesn't excrete magnetism. It just reflects the universe, and it moves, just like my finger's moving. It moves, but it doesn't. There's no force here when my finger's over here. Not a big surprise. I just don't. It's so distant from what my immediate perception would be, or my guess, or there's just nothing similar about how they're adding the facts and how I would have added them and how I have added them. There's no similarity at all. Oh, yeah, it appears like we're recording. Yeah, it's kind of funny. Never mind.
Rutherford's atom contradicted the known laws of science. The atom didn't care that it defied scientific convention. It's almost entirely empty space, and it's going to stay that way. I show no signs of shrinking down to the size of a grain of salt, and the Earth is, well, the size of the Earth.
I mean, this is just silly deduction, right? I mean, obviously, it doesn't have... You're saying it has to shrink. You're saying all this stuff has to happen. No, physics says it has to. So it's just nonsense. We absolutely know there's no point in having a solar system model if the solar system doesn't work. Why would you propose a model that doesn't work?
it's not getting smaller. Not surprisingly, all the established scientists of the day, including Einstein, were baffled. Scientific ideas they put their faith in all their lives had failed completely to explain the atom.
So it just doesn't make much sense, right? They already know what charge is. They know they have a net positive charge in the center and they have negative charge electrons on the outside. Why not just make it a magnetic model? And the problem is they haven't figured out yet. Okay, I think Rutherford did, frankly, from what I've seen of what he wrote. He clearly speculated on the existence of electrons inside the nucleus. And if the nucleus has electrons inside of it, I don't need orbiting. I can just stick magnets in different locations and the pressure attracting will balance the pressure repelling. And they'll just sit out there. I mean, the magnetic model works. And apparently they didn't even think of it, which is surprising.
The atom now required a new generation of scientists to follow in Rutherford's footsteps. Bold, brilliant, and above all young. It was crucial they had no loyalty or attachment to ideas held by previous generations.
So they think that's what this is always about, like the scientists are just stuck in their little ruts and they can't think outside of their little boxes and all that horse shit, when that's not, when Einstein made his quips, does the moon disappear when I'm not looking at it? I mean, that wasn't just some old guy saying, I don't get it. He was making a real argument that, whoa, you've gotten way too silly. And that's the part they just couldn't hear. Way too silly. Silly. Book. How much time are we going to waste?
One of the first of this new breed was Niels Bohr. He sailed from Denmark in 1911 and made his way to English soil.
So he's going to go exactly where Rutherford is, right? So they're going to be in the same building for like 4 years. Yeah. I mean, I'm sure they didn't, throw rotten eggs at each other.
Having finished his studies in Copenhagen, Bohr decided to move abroad and be at the centre of the new physics. The trail led him to Britain, Manchester University, and Ernest Rutherford. Bohr made it his mission to solve the puzzles of why the atom didn't collapse.
So he doesn't solve it. So this is like Einstein's solution of bent space. It doesn't answer any questions. It doesn't do anything because it's a non-real thing. So he's just going to take that model and say, well, if the orbit's in this particular location, it's okay. There's no collapse. There's no friction there. But there's friction everywhere else. And then it's going to instantaneously jump from energy levels, which is just absolute nonsense. If something happens instantaneously, when we know nothing can go instantaneous speed. So again, just an absolutely silly answer, and accepted by everybody for no good reason. And I can figure out why. Why is Niels Bohr the answer guy?
And why there was so much empty space. As one of the new breed of theoretical physicists, he was fearless in his thinking, and was prepared to abandon common sense and human intuition to...
So these are real things. I mean, common sense is an okay thing. Intuition, okay, that's just superficial thinking. So, but common sense is sort of important. Your physics should be able to survive common sense. It should be able to make your arguments a little complicated. Well, it's still sensible, and you still should be able to survive a common sense test. So if you're failing common sense tests, that's not a good thing.
Find an explanation. So in a leap of genius, he started to...
So again, this genius crap. No, this is a leap backward. This was falling face first into the mud.
Look for clues about the atom's structure, not by looking at matter, but by examining the mysterious and wonderful nature of light.
Yeah. I thought he was going to say math. Yeah, okay. Light's okay, but this isn't the answer.
atoms and light are clearly connected.
So this just tells you that the electrons are a certain distance. It doesn't tell you anything about orbits or any of that crap. So obviously this is the geometry, right? They never even draw this down, but you know, the first atoms, the hydrogen atoms, got to be pretty flat. And I would argue that it looks like most of the atoms are pretty flat. That's how things like carbon, graphite happens. It's pretty much got to be a done deal that all these atoms are layers, and that's why they can slide across each other, because they're not frictionless little balls. They have a shape that isn't spherical, but they don't even talk about this idea that you have to start with something that's pretty two-dimensional. You have to start with an electron and a proton, and the proton can't be everywhere, and it can't be orbiting all orbits, especially if it's connected to something. Then it can't be orbiting 360 degrees around the atom anymore, because then it can't be doing its figure eight thing with the atom it's bound to. So this can't work. But it is obvious that the geometry is going to demand, if you have a proton here and you have electron, 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 you could argue something like that. The next electron can only be here, because it has to see the proton, and then it has to have the pressure of the two electrons against it. So it's going to be in a solid position. So it all depends on what the first arrangement is, decides what else can build on it. So it's like building a snowflake or something. If it's ever going to be three-dimensional, it's going to be because it has planes that are dimensional, in 3 dimensions. But it's always going to be made out of plates.
Most substances glow when they're heated. And for centuries, people had realized that different substances glow with their own distinctive colors, a bit like a signature. So the green of copper, the yellow of sodium, and the red of lithium. These colors associated with different substances are called spectra. And Bohr's great insight...
I don't know why he didn't use an actual image of spectral lines, but whatever.
...was to realize that spectra are telling us something about the inner structure of the atom, that they could explain all that empty space.
All they explain is the rigidness of the electron's condition. So the more tension the electron's in, the faster its wobble, okay? And the greater the tension, the less the tension, the more loose, okay? Probably a better way to do that is to say distance-wise, okay? So the more tension, the more distance, because the more velocity. And the less tension, the less distance, because the less velocity. So you could just sort of understand, it just has to do with how much the damn electron is doing this. Because that's what's making photons. This is what makes photons. Yeah, and that's got to be at a high enough speed, okay, to be a higher energy or higher frequency photon has to be made by something vibrating at a higher frequency.
Bohr's idea was to take Rutherford's solar system model of the atom and replace it with something that's almost impossible to imagine or visualize. So sensible ideas like empty space and particles moving around in orbits fade away.
Right, so this is where the universe gets non-physical. So you go from this idea that you're supposed to be doing physics, and now you start just doing wooey religion.
And they're replaced with something that is one of the most misunderstood and misused concepts in the whole of science.
I don't even understand how it could be misused. How do you misuse complete garbage? But anyway.
The quantum jump. Now, it takes most working physicists many years to come to terms with quantum jumps. And in fact, Bohr himself said that if you think you've understood it, then you haven't really thought about it enough.
So the quantum jump is jumping from one position in the geometry to a different other position. They have it exactly backwards. The atoms on the inside are the ones really hard to move. The atoms on the outside are the ones really easy to move. Okay, so, and you're putting energy in, you're pushing the electron deeper into the atom. When you're getting energy out, it's because an atom has pushed out. All right, and that's the ones that are going to lose energy. energy that was holding things together is now escaping. You've taken something compressed and expanded it. That's a loss of energy. They have it completely backwards. They think as it's compressing, it's losing energy, and as it expands, it's gaining energy.
So I'm going to take a deep breath and in under 30 seconds try and explain to you one of the most complicated concepts in the whole of science.
It's really not that complicated, but anyway. Alright, should be back. It took forever. I downloaded the video, but nothing worked, so I had to use this stupid online fucking downloader, and it's just all pop-up windows. Hundreds of them. Anyway, so he's going to get to light spectra. And the simple argument I make is, look, electrons are sitting in space, and they're, in an atom. They're constantly jiggling. That's creating the infrared radiation, I would argue. And the more they move, okay, and the faster they move, the more space they push into. They compress the energy hitting them. So just like my hand gets bigger, as I move it forward, what I'm doing is compressing, okay, all of the light that would have reflected all the way back here is going to reflect here instead. So I'm basically taking stuff that was this far apart, it collides into my moving hand, and just like anything else, it's blue shifted, it's shifted into a new photon, a new piece of energy reflecting at a smaller frequency. There's a smaller frequency between the interaction. So the argument would be, when you excite atoms enough, you end up starting to produce the higher frequency light. And that just has to do with these energy levels that you're moving from one to another. So you're pushing on an atom and popping an electron that was comfortably in a position between, say, a proton here and two electrons, and it was sort of locked in this position, and you've squeezed it, pops up and out, and then it takes energy to push it back in again. So you can push things out by pushing on the atom, compressing it, and you push interior electrons. Now they're not in the nucleus, but they're interior. The exterior electrons are the ones closer to the nucleus than the ones further away. So we're just changing the position of electrons, and when you change their position, you don't quantum leap, you actually move. And so the electron moves quickly and a pretty big distance, and that's what creates the elements of a photon. One electron can't create a photon. It takes more than one. But anyway, that's a whole nother story. I mean, obviously, it's very hard to do physics in minute-long sound bites, but anyway. I have to click on this one.
He started to look for clues about the atom's structure, not by looking at matter, but by examining the mysterious and wonderful nature of light. Now, atoms and light are clearly connected. Most substances glow when they're heated. And for centuries, people had realized that different substances glow with their own distinctive colors.
Right. And so that indicates that visible light has something to do with a specific action, but then the other ends of the spectrum, the ultraviolet and the infrared, you have to concede is being caused by some subtly different phenomenon, because obviously our eyes can't see it, even though it would be useful. And they can't see it basically because the ultraviolet light is too hard on the atoms. It's that simple. It breaks them. And the infrared light is of too low a quality to be of any use to biological organisms. The resolution's not good enough. Too much work for too little bang for your buck. So that's why we see visible light, is because atoms do make a lot of it when you're agitating them.
Like a signature. So the green of copper, the yellow of sodium, and the red of lithium. These colors associated with different substances are called spectra.
So, I mean, I don't know why you didn't show spectrum lines. I mean, this doesn't really, you don't have to believe there's any copper because it's red, so, or green. So that is sort of, you should have just showed the spectral lines.
And Bohr's great insight was to realize that spectra are telling us something about the inner structure of the atom, that they could explain all that empty space.
So that's not what it's going to do. It's not going to explain any empty space. And you'll see from his analogy, it's not explaining empty space.
Idea was to take Rutherford's solar system model of the atom and replace it with something that's almost impossible to imagine or visualize.
So Rutherford is, again, associated with the plum pudding model of the atom. That's not a solar system. So it's just a weird, these stories don't match.
So sensible ideas like empty space and particles moving around in orbits fade away.
So I wish that's what happened, right? But they didn't get rid of the orbits. They taught me in school, okay, that this is what the electron's doing. When two atoms combine to each other, the electron's spending half its time with one atom and half its time with the other atom. So let's not say these guys were not believing in orbiting electrons, because they did.
And they're replaced with something that is one of the most misunderstood and misused concepts in the whole of science, the quantum jump.
So there's no quantum jump. There's just the fact that you can change where the electron is based on moving it to different positions oriented to the nucleus. The nucleus is not solidly positive. It's got negative in it. Okay, so there's rays of negative, rays of positive, and the electron can be situated in different locations where it's just looking for a balance. It ends up staying where there's a balance between the repulsive force and the attractive force. That's where it ends up staying.
Now, it takes most working physicists many years to come to terms with quantum jumps, and in fact, Bohr himself said that if you think you've understood it, then you haven't really thought about it enough. So
it's nonsense, in other words.
I'm going to take a deep breath, and in under 30 seconds try and explain to you one of the most complicated concepts in the whole of science.
So there's nothing complicated about it except its silliness.
But one that underpins the entire universe.
So again, they're not playing with this at all reasonably. I mean, if you start diagramming atoms, they end up being flat. You know, a proton and an electron, okay? It ends up being flat. The electron isn't everywhere. And especially with a hydrogen atom connected to something else, you've got to understand that there's no way the electron can be moving around all of the directions of the proton, okay? That's its nucleus. That can't be happening because it's busy doing the figure eight thing. It can't be doing all of this circular stuff. It can't be creating a round atom. Not possible. So, you know, the geometry of especially the rudimentary atoms has to be planar or flat, two-dimensional. And then you can start adding other planes to that dimensionality, like a snowflake. It's layers of planes, I would argue. That's a better theory.
Bohr described the atom not as a solar system, but as a multi-story building. The ground floor is where the nucleus lives.
Did he do that? Did he really use this analogy? I don't think this is his analogy. I don't think this is Bohr's tower. But anyway, obviously it's not a tower. Obviously it's, you know, it's not all the electrons are stacked in a row going in one direction. So again, the orbits were still intact. You know, I grew up in, you know, I was in, we're talking about the late 60s, if not, you know, 10, 11, 12 years. We're already into the 70s. The 70s, they were already still teaching an orbiting electron.
The electrons occupying the floors above.
And in orbits in the floors above. In the same orbits they said were impossible, they're somehow possible now. Because you call it a story, a tower, that somehow now you don't have the same problems. Electrons can be in orbits and it's not a problem. They don't fall into the nucleus.
Mysterious laws mean the electrons can only live on the floors, never in between.
So that would be purely a fact of, oh come on, I guess I have to draw this, right? I really have to. Just can't get away with it. You know, not, you know, it's got to be illustrated. So look, the simple argument being made by me anyway is that this is about geometry. Okay, so here I could draw what I would argue would be a helium nucleus. All right, 4 protons, 2 electrons. All right, and you could understand that, well, if I was to add another electron, I would add it here, or here, or here. Again, one of those locations would work. And then I could say, you know, and then I could start getting 3-dimensional. But if I stayed 2-dimensional with this configuration, you can understand that the next place an electron would be here. Here would be a perfect location, right? I mean, it sees directly the proton, so it has a strong attraction, and then it's got the repulsive force working on it this way, you know, in this way. The electrons are repelling, the proton is attracting, the electron stays in this position. So this, you know, wrong color. All right, so this electron, you could argue, this is a nucleus, okay, but I just mean the exterior electrons I'm building on top of the nucleus. So you're just saying the nucleus has a shape where it has places where there's electrons and has places where there's protons that you can see. So this is one of the first exterior electrons, let's say. And it's going to be able to find a good location here, all right, and then you'd say another location would be here, you know, because this is still visible to the proton and it's got these repelling electrons this way. So that's the next energy level. So this would be one energy level, this would be the next energy level, third energy level, all going out. All right, just based on the fact that there's more protons than electrons in the nucleus, twice as many. So it's a net positive. And so the idea is if I hit this electron with energy, I squeeze this, then I push this, and if I push it hard enough, it pops over here rather than staying here. That's the idea. So the energy levels are, the electrons are more secure the deeper they are, and they're less secure the further out they are. And the idea is you have to push the ones on the outside into the inside, and when you release one from the inside, okay, you create less pressure on the inside. And so you release this motion into the universe. An outward moving electron is going to increase a frequency. An inward moving electron is going to decrease a photon's frequency. Come on. Thank you.
And other mysterious laws mean that sometimes they can instantaneously jump from one floor to another.
So there's no need for this instantaneous thing, right? No need at all to bring up any idea of anything happening instantaneous. It's a real 3-dimensional universe. We know nothing can travel distances instantaneously. There's no such thing as instantaneous speed. So why this concept could even get off the ground is just unbelievable. Why would physicists do this? Create this idea of an instantaneous electron motion. Electron went from here to here instantaneously. Why would that ever happen?
These are what we call quantum jumps. Now, Bohr had absolutely no idea what these laws were, but thinking like this allowed him to make...
So there's no laws, they're just magical propositions. You're just saying the electron has magical powers. So it has the magical power now of being in an orbit, but it doesn't lose any energy, and it now has the magical power that it can jump from one orbit to another orbit instantaneously, at instantaneous speed. So the idea would be, look, when the electron is moving, it's hitting stuff the whole time and causing reflections. If it moved instantaneous, is it still going to reflect? If my hand moves, are we going to say none of the light hit it in the time it moved? I mean, that would be ridiculous. So obviously this doesn't work with a force field. You know, if you understand force and matter being the two things that are interacting, this won't work, because that instantaneous motion has to be in a field of energy.
A startling prediction. When an electron jumps from a higher floor to a lower one, it gives off light. More significantly, the color of the light.
So that's the funny part, right? Because that's exactly backwards. That's the electron moving towards the nucleus. It's moving away from the external world. It's receding. It's going like this. It's reflecting less. So anything that was going to bounce off of it is now going to be redshifted. It's going to get a larger frequency. So it's going to go from being infrared to being microwaves or being radio waves. It's not going to be visible light. If you want to make visible light, you need to compress the infrared radiation. You need to take infrared radiation and compress it to make visible light. It has to be moving out, not in.
It depends on how big or small a quantum jump the electron makes. So, an electron jumping from the 3rd floor to the 2nd floor might give off red light. And an electron jumping from the 10th floor to the 2nd floor, blue light.
Right. So that's the complication. Now, I would argue that it won't do that blue light thing. Okay, so it won't do the ultraviolet. So it will do blue, but it won't do ultraviolet. To get ultraviolet, you have to have 2 mechanisms. You have to have more sources of electron motion.
To test his new theory, Bohr used it to make a prediction. Could it explain the mysterious signature in the spectrum of hydrogen? After months of calculating furiously, he finally came up with a result.
So this is the weird part, because the hydrogen's only 1 electron, right? So the 1 electron has to move from different energy levels. So I'd argue that it's not gonna care about anything called an energy level. It's just not. Okay, so pushing it out and pushing it in is all you can do, is move it in and move it out. And how far you move it is just about how much energy you have disturbing the hydrogen atom.
And his prediction was
where it started and where it finishes, you know. So in a way you could say it's about how much pressure the hydrogen's under. And each atom is going to be, you know, they're banging into each other at different angles, different speeds, and so they are constantly changing how much their spring is loaded, so to speak. So they're all starting from a different position. And so there's a certain amount of ones that would be regular, I guess. So I would have to go over the hydrogen atom to see, but just trying to think of what other... Now, let's just continue.
surprisingly accurate. For the first time...
It's because it's hydrogen 2, I think, is the problem. They're reading the signature of molecular hydrogen. You know, the 2 hydrogen atoms have combined and are sticking to each other, and that's what this is a signature of.
Ever, it looked like the spectrum could be explained. And back in 1913, that was big news. But Bohr's new idea rested on a single, seriously controversial supposition. Why should the electrons in the atom behave as though they were in a multi-story building? And why should they magically perform quantum jumps from one story to another?
Exactly, so it just brings up a bunch of wooey crap. So yeah, not a likable theory. Let's understand there's 3 versions of hydrogen. Okay, just, you know, so it's not like there's just, you know, a proton and an electron. There's the hydrogen that's a proton and an electron, and then another proton and an electron. You remember, there's the 3rd version, I think, is 3 of those, and then you get 2 helium nucleuses with the total of 4 protons. If you just understand the neutrons are a proton and an electron, I'm just saying it's 2 protons, 2 neutrons, which adds up to the same thing as 2 electrons and 4 protons.
There was no precedent for it anywhere else in science. When one physicist claimed that the jumps were nonsense, Bohr replied, yes, you're completely right, but that doesn't prove the jumps don't happen.
Alright, so again, this isn't very good science, right? You know, to say that somehow, you know, it's fine to call it just speculation, but that's all it is.
Only that you cannot visualize them. That not being able to visualize things seemed to go against the whole purpose of science. Older scientists in particular felt that science was supposed to be about understanding the world, not about making it.
Well, physics in particular are supposed to be about physics, physical things, okay, not magical things. It's not supposed to be a religion.
up arbitrary rules that seemed to fit the data. Conflict between the two generations of scientists was inevitable.
Alright, so I don't think there's any proof that this was generational. No. So, you'd have to show me that.
Bohr's weird new atom and his crazy quantum jumps were a shot across the bow of traditional classical science, and the old school reacted angrily. Leading the traditionalists was giant of the physics world Albert Einstein. He hated Bohr's ideas, and he was going to fight them. Anything to save the world of order and common sense from this assault by madness.
So again, and this is the irony one, because, obviously Einstein's relativity theory is dependent on some notion that there's some special bent thing. Okay, there's nothing that's bent. Nothing is bent. I mean, it's, So Einstein's already guilty of his own wooey bullshit.
Bohr, though, was undeterred, and as the 1920s dawned, the battle lines for one of the greatest conflicts in all science were drawn. So far, the debates about the new atomic physics had been polite and gentlemanly. Now, the two sides wheeled out their big...
So this is really kind of the wrong premise for the two sides arguing, right? I mean, Einstein was more specific about the real quantum rule. I don't know how much he cared about, modeling atoms.
Guys, two of the greatest names in physics. They were two very contrasting characters who loathed each other. For the new revolutionary science was a buttoned-up, uber-competitive German called Werner Heisenberg. For the conservatives was a debonair, Byronesque Austrian called Erwin Schrödinger.
So these stories are so strange, but Schrödinger was an ally of Einstein's, but then you have Schrödinger's wave equation, which Schrödinger didn't like the interpretation people used it for, but it still was kind of a woo equation. Well, let me put it this way. I don't know whether he called it a wave equation or not. All right, so, but the point is that it was an equation basically just saying, look, you can, if you want to itemize everything and you know where everything is, then you can predict the next iteration of the universe. And obviously this is the Heisenberg-Schrödinger conflict, because Heisenberg is saying you can't know because it doesn't have a real place, and that's what Bohr is arguing, that nothing has a location. When the simpler argument is we just can't measure it.
Erwin Schrödinger, passionate and poetic, a philosopher and a romantic.
This is the part that it's a little hard to believe, all this wooey parts. I've seen some video of Schrödinger. He's not exactly Mr. Drake Beefcake. It's not exactly the epitome of ladies' man.
He wrote books on the ancient Greeks, on philosophy, on religion. He was influenced by Hinduism. He was also a very flamboyant character, cool, suave, sophisticated, a dapper dresser, and a big hit with the ladies. Schrödinger's promiscuity was legendary. He had a string of girlfriends throughout his married life, some of them much younger than him. In 1925...
hardly surprising, really. So, yeah. This is the story of, Joe Sixpack. I mean, this is so common. But, they want to make it all into something.
38-year-old Schrödinger stayed at the Alpine resort of Arosa in Switzerland for a secret liaison with an old girlfriend, whose identity remains a mystery to this day.
So they know the story. They did all this stuff, but they don't even know who the woman was. I mean, it's hilarious.
But their passion proved to be the catalyst for Schrödinger's creative genius. Another physicist said of Schrödinger's week of sexually inspired physics, he had two tasks that week: satisfy a woman and solve the riddle of the atom. Fortunately, he was up to both.
And how do we know any of that, right? They don't even know who the woman is. Did they interview her? It's just, you're just saying, what the fuck is this bullshit? Yeah, just putrid.
He took de Broglie's idea of mysterious pilot waves guiding electrons around an atom.
So he didn't even, it's not even, there's no continuity here, right? He's talking about de Broglie now, and he didn't even give us that whole wacky story. And, this is like a complete jump in the story.
One crucial step further. He argued that the electron actually was a wave of energy, vibrating so fast it looked like a cloud around the atom. A cloud-like wave of pure energy. And what's more, he came up...
So this really doesn't sound like Schrodinger that I heard in a tape recording where he was talking about the fact that electrons aren't wootons. They can't tell whether we're thinking about them or not, and they can't de-entangle, and they can't do any of that crap. So this doesn't sound exactly consistent with Schrodinger. And it certainly doesn't sound consistent with a Schrodinger who invents Schrodinger's cat to mock quantum mechanics.
With a powerful new equation which completely described this wave. And so described...
Let's understand, a wave is describable as just a period between events. That's what a wave is, a period between events. All right, so it could be called the period equation. Okay, that wouldn't sound too cool. Or the frequency equation. It could be called a lot of other things besides a wave equation. That would, in my opinion, be more accurate. Waves are just action over a period of time.
The whole atom in terms of traditional physics. The equation he came up with we now call Schrodinger's wave equation. It's incredibly powerful. What's unique about it is that it features a new quantity called the wave function, which Schrodinger claimed completely described the behavior of the subatomic world.
Right, he only said that because it has to have in it all of the information, and we can't even get that information, so it doesn't mean anything. If you don't already know what it's going to do, this equation won't do you any good. It doesn't really predict anything that you don't already know. It just consolidates it into a formula. But that little forky thing isn't like 15. It isn't some easy number to derive. That little forky thing represents knowing position and velocity and all kinds of information. And we can't get any of that information. I mean, just realize, people like Sean Carroll say there's only one Schrodinger equation for the whole universe. There's only one. And that's the only one that's in effect. And that's, he uses this as an excuse to just say there's only one universe we actually exist in, and there's about 10 zillion that we partially exist in.
Schrodinger's equation and the picture of the atom it painted, created during a sexually charged holiday in the Swiss Alps, once again allowed scientists to visualize the atom in simple terms.
So it doesn't visualize anything. They can't draw a picture of it. It's just complete bullshit. Okay, it doesn't make it any easier to understand at all. So it's just nonsense. If it could make things easier to see, he'd show us this easier to see picture it produces. It doesn't produce an easy to see picture.
It's hard to overestimate the relief Schrodinger's idea brought to the traditional physics community.
Why would that be? Okay, it's a Wu equation. It's not much better.
Though his picture of the atom was, at least it was a picture. And scientists love pictures. They allowed them to use their intuition. But there was still a deep, nagging problem. One that the radicals felt Schrodinger just couldn't reconcile. His new theory still couldn't account for Bohr's strange, instantaneous quantum jumps. The time had come for...
Nothing can account for it because it's nonsense. Instantaneous isn't a real thing that happens in this real universe.
The radicals to hit back. In the summer of the same year, one of Niels Bohr's protégés, Werner Heisenberg, was travelling to an obscure island off the north coast of Germany. He was fiercely competitive and took Schrödinger's ideas as a personal affront. He felt strongly that the strangeness of the instant quantum jumps was actually the key to understanding the atom. He thought the atom was so unique and unusual, it shouldn't be compromised through a simple analogy like a wave or an orbit.
So this is all, like I said, you go back to Newton and Benjamin Franklin and these people, and they were getting the idea that this stuff moved from thing to thing. They were getting the idea that, the atoms are all a bunch of the same thing, okay? They don't have all this woo in them. So this is just,
Or even a multi-story...
This will get to something more important. I'm sorry that all this crap comes first.
...building. He believed it was time to give up any picture of the atom at all.
Just think of that statement, that the universe has to be made out of stuff simpler than we are, okay? We're not made out of stuff more complicated than us. So, come on.
Werner Heisenberg, one of the true geniuses of the 20th century. Young, athletic, a great mountain climber, an excellent pianist. He was also an
kind of a Nazi, whatever.
exceptional student. At the age of just 20, he was well on his way to finishing his PhD and being courted by the great universities across Europe. Now, in the summer of 1925, he was suffering from a particularly bad bout of hay fever. His face was swollen up almost beyond recognition. He decided to escape alone here to this beautiful but isolated island of Helgoland. He walked along the beaches, he swam, he climbed the rocks, and he pondered.
So this is physics, all this bullshit. So I hope the future doesn't do this to me, okay, where it just makes up a bunch of silly stories about what day, I thought of this and what day I thought of that. Just what crap.
Ever since he'd encountered atomic physics, Heisenberg felt in his bones that all human attempts to visualize the atom, to model it with familiar images, would always fail. The atom, he believed, was too capricious, too strange.
What that means, capricious how, strange how? You mean it has a whole bunch of battleship-type functions, it has all kinds of crap, and somehow evolution can't find out how to use any of those instantaneous functions. Fuck. It's just bullshit.
To ever be explained that simply. So he decided to abandon all pictures of it and describe it using pure mathematics alone. But as he pondered, he realized that the atom didn't just defy visualization, it even defied traditional mathematics.
Just this whole idea that you still have to have a structure. You have to have some base structure before you can talk about mathematical relationships, and they're just going to be geometry. It's just going to be Pythagorean. Okay, that's the formulas. That's rational mathematics. It's just coming up with mathematics gives you a shorthand, all right, recognizing that what the geometry means. And there's clearly geometry involved in atoms. That's why there's 96 natural atoms, is because there's only 96 geometric places you can put these electrons and protons inside of a nucleus without them falling apart. Play.
It was while he was here on Helgoland that Heisenberg had an incredible revelation. He realized that in order to describe certain properties of atoms, he had to use a strange new type of mathematics. It seems that certain properties like where an electron is at a given time and how fast it's moving, when multiplied together, the order in which you multiply them matters. Let me try and explain. If we multiply two numbers together, it doesn't matter which order we do it in. So 3 times 4 is clearly the same as 4 times 3. But when it came to atoms, Heisenberg realized that the order in which he multiplied quantities together gave a different answer. This quickly led him to other discoveries, and he was convinced that he'd cracked a code in the atom, that he'd somehow found the hidden mathematics within.
So this is all just mush. So, frankly, I can't even show it. It's so mushy. you know, this problem where somehow you can't do the multiplication in a straight order. I mean, this could just be called the three-body problem or some other problem. Yes, as soon as you have more than two things interacting, you're in trouble.
He was so excited. He was also very scared. That night, he climbed to the top of a rock and sat there waiting till dawn. He called it his night of Helgoland. When he returned to his university in Göttingen, he told his colleague Max Born about it, and they then worked together intensely for several months, developing a whole new theory of the atom, a theory that today we call matrix mechanics.
So calling it something and that something meaning anything is, you know. So this is the kind of crap that Einstein also uses, you know, to create his tensor. So they just create some whatever set math.
Matrix mechanics uses complex arrays of numbers, rather like a spreadsheet. By manipulating these arrays, Heisenberg and his mentor, the brilliant physicist Max Born, could accurately predict atomic behavior. But from
So they illustrated by what? What did they predict? Waiting.
Einstein and the traditionalists, this was pure scientific heresy. An atom can't actually be a matrix of numbers. Surely we're made of atoms, not numbers.
Well, it's made of a structure, and there's clearly mathematics to defining what a snowflake will do, or any crystal will do. So that's rational, but this isn't rational.
Back in Copenhagen, Bohr and Pauli were thrilled with matrix mechanics. So what if we couldn't imagine the atom as a physical object? They exulted in the purity of the mathematics.
So again, just whatever the purity word even means. I mean, what does it mean? Pure to who? It's like saying it's pretty or ugly. Isn't that going to be subjective?
And launched into vicious attacks against Schrödinger's vulgar sensual waves. Heisenberg wrote, "The more I reflect on the physical portion of Schrödinger's equation, the more disgusting I find it. In fact, it's just..."
So isn't that, this is a giveaway. They're both insulting their baby as bathwater. And the argument is maybe they were both right. Schrödinger was right to see Heisenberg as rubbish, and Heisenberg was right to see Schrödinger as rubbish. They're both bad guesses.
Bullshit. But Schrödinger was equally scathing of Heisenberg, saying he was repelled by his methods and found his mathematics monstrous.
So in all of this, there was no illustration of some key insight produced here. You know, that we got some kind of insight into how atoms work that we couldn't have gotten without these silly equations. So these silly equations didn't advance anybody's understanding of anything.
Munich in 1926, their enmity began to reach boiling point. Schrödinger was to give a lecture on his wave equation. Heisenberg scraped together the money to travel down to Munich for the lecture, to finally come face to face with his rival. What was at stake was more than just...
Apparently they got over some of this hostility, because later he's going to talk about the Solvay conference, where they got actually images of them coming out of the building together.
Heisenberg's reputation. He believed Schrödinger's simplistic approach wasn't just misguided, but totally wrong. And his intention was nothing less than to destroy Schrödinger's theory. Schrödinger delivers his lecture on the new wave mechanics to a packed audience, a standing room only. He writes down his new wave equation.
Oh, shit. Where's Forky thing? There he is. There's Forky thing again.
To Schrödinger, this describes a real physical picture of the atom, with electrons as waves surrounding the atomic nucleus.
So it's just about distances, and it's about how often, they vibrate at what rate. So again, it can be it can be reduced to just something vibrating. No wave needed.
24-year-old Werner Heisenberg is in the audience. He can hardly contain himself. At the end of the lecture, he stands up and delivers a monologue attacking Schrödinger's approach. For Heisenberg, it's impossible to ever have a picture of what the atom is really like.
It's too bad they don't have video of all that kind of stuff, right? It'd be really great to see the actual event versus the stories told about the event. And it is kind of disappointing because, some of this stuff, they did have the capacity. They did have movie cameras. This was all possible. And nobody thought it was important enough to do. Surprising.
The audience is on Schrödinger's side. They much prefer his simple physical interpretation to Heisenberg's abstract, complicated mathematics. Heisenberg is booed. He's told to sit down and be quiet. He leaves...
Yes, but he's being a rude asshole, okay? I mean, this isn't the place you do it when the guy's giving his lecture, okay? That's a presentation of his model, and the idea is to challenge the model, not with a competing model, but with arguments against the model, blah, blah, blah. And yeah, you don't be an asshole about it.
Is the lecture sad and depressed? Heisenberg returned to Copenhagen with his confidence severely dented. There at the Institute, he and Bohr reached their darkest moment. Almost all of the scientific community was against them. They felt isolated, desperate. Their backs were against the wall.
More just storytelling. Bohr doesn't seem like the kind of guy who ever gives up on his God theory.
Despite this, they stubbornly refused to give up their controversial theory.
So they didn't really explain how Heisenberg and Bohr got on the same, or were allies. He just talked about it was Niels Bohr who helped him with the math, and now it's Bohr again. So, it's very confusing.
Attic room was Heisenberg's study back in 1926. Bohr would come up here night after night, where he and Heisenberg would argue about the meaning of the new quantum mechanics. They would argue so passionately that on one occasion, apparently, Heisenberg was reduced to tears. And then, as Heisenberg stared out of his attic window in despair at the park below, an extraordinary thought occurred to him.
So, you gotta wonder why they were meeting there. Whatever. Why wouldn't they have these conversations at the Institute?
It struck him why an atom can't be visualized, why it can't be understood intuitively.
Again, so this intuition word is just kind of disgusting. And the idea is to understand it mechanically, because that's the universe we exist in. The forces are so consistent. Photons travel billions of light years. I mean, it's just bullshit to create all this artificial fake noise that doesn't exist. Things travel dead straight lines. I mean, this is just such bullshit.
It's not just because it's tiny, tricky, and difficult. It's because it's inherently unknowable.
Unphysical. It's inherently not physics.
He realized that there was a fundamental limit to how much we can know about the subatomic world.
So, and just conveniently, we can't disprove that because, the shit's too tiny and we don't have tweezers small enough to pick at it. And so, yes, they conveniently have the out that I can't disprove the nonsense because, yes, I can't take a picture of it. But it's not doing what they say it's doing.
For instance, if we know where an electron is at a particular moment in time, then we cannot know how fast it's moving. But if we knew its speed, we wouldn't know its position. This ambiguity.
So again, this just has to do with our technology, right? We can know where it is if we let it crash into something. We say, hey, there it is. It's right here, this little spot here on my hand, right? Okay, so it's not going anywhere because we've destroyed it. So we can't tell where it was going because we destroyed it. I mean, that's just duh. But why would I believe that's because it's impossible for us to know? And it might be physically impossible. But it doesn't mean that the electron or the proton or the helium nucleus or the person isn't operating in really strict geometric momentum rules.
Isn't a shortcoming in the theory itself, nor is it due to the clumsiness of the way we carry out our measurements. but a fundamental truth about the way nature behaves at the subatomic scale.
So it's just saying that they're all woo particles, that there aren't any particles, they're just all some sort of wooey little spirits, and they just float around in space, so that'll be, and then they can be in all kinds of locations. You know, right now, there's energy leaving me, and it's, you know, heading for Venus, but that energy is retracted because I put my hand up here and I hit the photon, and so now that photon that was going to Venus is going, it's in my hand now. I mean, it's ridiculous theory that energy spreads out, but it all lands in one place. I mean, it's just bullshit. Somehow it's all retracted from all the other places it was heading. I mean, bullshit.
It became known as Heisenberg's uncertainty principle.
And there's the principle is you can make up anything you want if it's if nobody can disprove it. So that's it's just a God theory. You can just say it, and there's no way I can prove it didn't happen or it's not real because there's no way to test it.
And it's probably the most profound, incredible, yet unsettling concepts in the whole of science.
No, there's lots of them. All of your concepts are incredible nonsense. 90% of physics is incredible nonsense. Uncredible nonsense. Either there's no evidence or the evidence is weak and feeble. And in the case of mv squared, as I'll keep pointing out, there's obvious evidence against it. 25 times the fuel to go 5 times faster. It doesn't fucking happen. There, theory proven.
What Heisenberg had uncovered through his abstract matrix mechanics was a deep and shocking truth about the atomic world.
So again, they're just telling us we have to believe this nonsense. We don't have any alternative because of the glaring huge piece of evidence he showed us. Oh, that's right, there was no evidence.
Atoms are willfully obscure.
Why even say that? Why say something like they're willfully? We're not even willful. Fuck you, there's no willful in the universe.
We can never fully know an atom's position and speed simultaneously.
And why would we need to, frankly? So even that's kind of a joke. We know if I point the laser beam, we know where the light's going to go. So all of this bullshit about uncertainty doesn't mean anything.
The atomic world just refuses to allow that to happen. It was completely mind-boggling. But once they accepted it,
It's fuck-tarded is what it is.
Heisenberg and Bohr found a boost of confidence to be even more bold. They realized uncertainty forced them to put paradox right at the very heart of the atom.
And again, why would anybody do this and call themselves a scientist or a physicist? This is a God theory, all right? This is, it's just made up shit.
Atoms are not just unimaginable, they're self-contradictory. They behave both like particles and waves.
So that's the famous line, right? And we know that that's all based on the two-slit experiment, and I've already explained it over and over again. That has nothing to do with any waves. So there is no duality. There's never an issue of one single photon going through both slits. It always has to be more than one photon involved, and they're being broken at the surfaces, and you're just putting the pieces back together again. So they don't even know what a single photon is. I've explained those experiments. They never have single photons in the experiment. I already pointed out how Veritasium tried to do the experiment in a modern way, and he couldn't get it to work if he did it the right way. So he had to basically force there to be more photons in the experiment, shorten the time of the experiment, that is, increase the density of photons, to get it to work, because it won't work. One photon can't do what they claim. One piece of a photon. They need a lot of pieces.
And it gets weirder. When you're not looking at an atom, it behaves like a spread out.
So this looking at thing against, oh, this is so perverse. And so this is where Einstein said, oh, does the moon disappear when I'm not looking at it? I mean, it's a ridiculous idea. And all of this looking at thing doesn't mean anything unless you think it has something to do with our consciousness controlling things or some kind of bizarre, idiotic crap like that. Somehow we make the light beam that hits the object and then the light bounces back to our eye. We know none of that happens. So we know the same photons that hit something and go to my eyes are the same photons that hit something and don't go into my little fucking tiny pupil. So we know whatever this entanglement crap is, it doesn't need a person to read the film. It just needs the camera. There doesn't have to be any film in the camera. Okay? The fact is, every single piece of material, electron and proton in this universe is constantly being hit by force. It can never be free to be entangled. It's always radiating its location. It's always sending a signal to the universe. I'm a proton. I'm here. Every electron and proton is reflecting the energy hitting it constantly. And every single time it moves anywhere, it's sending a signature. And all we have to do is put film and we'll see the signature. It's just such bullshit for them to imply that somehow anything can escape being outed all the fucking time. Again, the Schrodinger cat thing comes up here, blah, 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 blah. Oh, terrible.
Wave. But when you look to see where it is, it behaves like a particle. This is insane. First,
right, it is insane. It's stupid. It's start over. You're way off track. It's nonsense. Just forget about that crap. So it doesn't have anything to do with reality.
Atoms couldn't be visualized at all. Now it seems they change completely in character depending on whether or not you're looking at them.
So again, all of this comes from the two slit. The idea that they had detectors, they never detected any photons. It's all bullshit. You know, so all these exaggerations and perversions of the actual experiment, what it actually produces, and then they just let this ball roll on complete nonsense. Completely stuff that just isn't. The evidence isn't what they claim it to be. The experiments aren't doing what they claim them to be. Again, he tells us that it's the same thing. A double-slit experiment in photons is the same thing as shooting an electron at a hunk of nickel. Bouncing an electron off nickel is the same thing as a two-slit experiment.
The uncertainty principle had changed everything. It revealed a shocking contradiction at the heart of nature. Everything we see is made of atoms, and yet atoms themselves are unknowable. They can only be understood through mathematics.
See, that's even the disgusting part, because they don't have any mathematics that have anything to do with anything physically rational.
For the first time, for Bohr and Heisenberg, everything about the atom fell into place.
It's just unimaginable how this silly holy ghost nonsense could be coherent to anybody. This is as bad as, angels and demons.
By the autumn of 1927, full of confidence and smarting for a fight, they knew they were finally ready to take on the conservatives.
Again, they're calling Einstein a conservative, whatever the fuck that is.
For this physics showdown, they chose the Solvay Conference in Brussels. All the world's leading atomic physicists would attend. If Bohr and Heisenberg were successful, then they would lead a total scientific revolution. This is amazing. I'm looking at original...
Yes, it's amazing that these people get to decide what everybody else has to believe.
Footage of the Solvay delegates coming out of these doors. There's Bohr talking to Schrodinger, and there's Heisenberg behind them.
Right, so, you would think they wouldn't really be very social if they had such great animosity for each other's theories.
And there's Pauli, strange-looking guy. Oh, and there's Einstein.
Oh, Jesus. That's strange looking.
Coming down with a big smile on his face. For the week of the conference, all that the delegates could think and talk about was Bohr's quantum mechanics. with uncertainty now a central plank. It was a truly formidable theory.
I just don't understand. That's the scary part, right? How, you know, and as they talk about this, you know, Einstein, Bogolsky, wrote this paper, this whole argument about entanglement, and it's wooey nonsense, and it was all turned upside down. Schrodinger's cat was turned into a real, like, oh yeah, it really is half alive and half dead. Even though you can realize that, no, the cat is in a box. If it's breathing, it's creating a signal that can be heard. You know, it's changing the amount of carbon dioxide in the box. There's a ton of things that are already outing its condition. So it's just a lie to say nobody's looking, that nothing is looking. Obviously, the universe is seeing. The universe is sending all kinds of signals that will demonstrate it's one or the other. And we're just saying, because we're just going to pretend, well, we're not listening for any of that. We're not paying any attention. That means we can pretend it's actually in two states. When, no, it's never in two states.
And over the week, the final showdown played out between Bohr and his arch-rival, Albert Einstein. Einstein hated quantum mechanics, and every morning he'd come to Bohr with an argument that he felt picked a hole in the new theory. Bohr would go away very disturbed and think very hard about it, and by the end of the day, he'd come back with a counter-argument that dismissed Einstein.
Well, it'd be nice if we all had that, right? If we had some sort of somebody who was taking notes somewhere, you know, to hear what the arguments were and what the counter-replies were.
Criticism. And this happened day after day until by the end of the conference, Bohr had brushed aside all of Einstein's criticisms, and Bohr was regarded as having been victorious.
So somebody was listening to all of their conversations and declared one person a victor. So this is, you know, he's just rewriting the history here and pretending everybody was in on exactly what Einstein and Bohr were talking about in their own private conversations. And somehow everybody took a vote who won. Bullshit.
And with that, his vision of the atom, which became known as the Copenhagen interpretation.
So this is the weird part, okay? It's just, you know, because this interpretation really isn't the Copenhagen interpretation. I mean, the Copenhagen interpretation has to do with the fact that you're saying the photon splits in two and goes through both slits and interferes with itself, all right, which is, I don't see what that has to do with this Heisenberg element.
Was suddenly at the very heart of atomic physics.
And so you can almost argue that photons could get away with traveling through the universe undetectable if they don't hit matter, because they don't interact with force. But by their own theory, the photons are bent by gravity. So even they can't escape, because the very fact is they're going to interact with the gravity, and they're going to both... You can't interact with something without you affecting it also.
At the end of the conference, they all gather for the team photo. Never before or since have so many great names of physics been together in one place. At the front, the elder statesman of physics, Hendrik Lorentz, flanked on either side by Madame Curie and Albert Einstein.
Right, so where the fuck, why isn't Bohr in those three, right? Why isn't he, if he won such a victory, why isn't he in the middle?
Einstein's looking rather glum because he's lost the argument. Louis de Broglie has also failed to convince the delegates of his views. Victory goes to Niels Bohr.
So Bohr is way the fuck over there, right? So, I mean, this is a story, right? You know, I mean, obviously this wasn't what the conference was about, Einstein and Bohr. Or they would have been just opposed to each other in some way, one in front or one behind, whatever. So what a pile of crap.
He's feeling very pleased with himself. Next to him, one of the unsung heroes of quantum mechanics, the German Max Born, who developed so much of the mathematics.
So that's the other guy who did the math crap. You know, Born and Bohr, these are names you could easily confuse.
And behind them, the two young disciples of Bohr, Heisenberg and Pauli. Pauli's looking rather smugly across at Schrodinger, a bit like the cat who's got the milk. This was the moment in physics when it all changed. The old guard was replaced by the new. Chance and probability became interwoven into the fabric of nature itself, and we could no longer describe atoms in terms of simple...
So there's nothing wrong with probability. There's a big problem with saying something changes it entirely, like the idiotic Feynman theory that every single photon that goes through the slits somehow is randomized. When you know most of the photons just plow right straight through. That's why there's a big bright blob right across from the slits, is because the fact is, no, they weren't randomized. It's just fringe photons, or all the fringe photons are all being created by photons that went by the surface. And the giveaway is the smaller you make the opening, the more fringe you get. And the bigger the opening, the smaller the fringe, the amount of light fringing.
Pictures, but only using pure abstract mathematics. The Copenhagen view had been victorious.
Says him. So I think obviously that's a question, and nobody took a vote, and so bullshit.
Although Einstein went to his grave never believing quantum mechanics, Solvay 1927 was the turning point at which the
So it really wasn't, okay? The paper they, him, Schrodinger, and the other guy wrote, okay, the Schrodinger cat thing, that was all later.
Of the science establishment came to embrace the Copenhagen interpretation. And that interpretation is still accepted today.
All right, so that's still nonsense too, because Sean Carroll's pointed out that it's only 1/3 of physicists who believe it. And now it's even less because they have even more interpretations. And so it's not any way clear that there's any decided majority for one interpretation over another. And that's just more evidence that they're probably all wrong. They're all bad ideas. New universes is just as silly as particles without any substance.
All the physics that I use in my research,
Who cares?
certainly the quantum mechanics that I teach my students,
Who cares?
and it fills the textbooks on my shelves,
Who cares? Yeah, your religion.
is based on ideas that were hammered out and crystallized here at the Solvay conference in October 1927.
So why don't we have some great document regarding this conference and who spoke and what they said?
In a sense, everything I know about the way the world around me is made up started here.
Just amazing, Started with mushy, wooey goop. But this is why they don't know any physics, right? I mean, I'm sure, what do we think this guy will say? If I say to him, do you really believe it takes 25 times the fuel to go 5 times as fast? Do you really believe it takes 100 times the fuel to go 10 times as fast? Do you really think so? Did you have 100 times the damage? Not 10 times, 100 times. I mean, do you really believe we, with all of our technology, all of our land on the moon technology, we can't make a ballistic pendulum that can collect more than 1.8% of the energy the bullet has? No, it's not 1.8%. No. It's 0.018%. 1/1000th of the energy. That's all we can collect. 1/1000th of the bullet's energy. Do you really think that's true? Do you really think the 1,000-year-old lever that tells you clearly what kind of momentum equals what momentum? All right, the 1 pound going 4 times the velocity equals the 4 pound going 1 velocity. The lever's lying. And it's just so bad.
The quantum mechanical description of the atom is one of the crowning glories of human creativity.
It's disgusting. The silly religion. It's just, ooh.
Over the last 80 years, it has been proven right time after...
So this bullshit, more about bullshit, okay? We're proven right doing what? Where? Where is your proof of this thing doing something? Calculating a number you already know. So we're all back to this stupid magnetron thing, and somehow they're calculating the mass of the electron, I think. I don't know exactly what they're doing. But they know what the answer is going to be, and so they're just, doesn't mean anything.
The time, and its authority has never been in doubt.
Oh, it's just amazing.
It's a monumental scientific achievement.
Oh, God. Praise God. Glory be God. This is fucking Muslim shit.
Between
Babble, babble. Force people to believe crap.
1905 and 1927, science changed our view of the world. It also changed our view of science itself.
Well, you didn't fool me as a kid, and you didn't fool me now. And now I have the evidence to argue against you, because I can just point out that, yes, there's a perfectly rational explanation for what's happening in the double-slit experiment. The photons are just being broken and rebuilt on the screen. It's not complicated at all, and I can tell you for sure there's no such thing as 1/2 mv squared. It's just a fake mathematical piece of crap. And it's not MGH, it's MGT.
As scientists probed the tiniest building blocks of matter, they created the most successful and powerful theory.
See, you keep saying it, successful and powerful theory. Where is there any evidence of that? What has it done? Except to get you a paycheck. I mean, besides that, what has it done?
Theory ever, quantum mechanics. It allows us to describe what everything in the universe is made of.
Oh, brother, it's made of mush. Fields of mush.
Interacts and how it all fits together.
Bullshit. And again, they're going to go into the strong force in the next video, so I'll be able to make a lot of fun out of that.
But it comes at a huge price. At its most fundamental level, we have to accept that nature is ruled by chance and probability.
Bullshit. So you don't have to accept any of that nonsense, that anything is jumping or hyperspacing or hyperlooping or hyper anything. It's not happening. The universe is the most solid, consistent, reliable thing out there. It's grass grows, wind blows. I mean, it's just bullshit.
Heisenberg's uncertainty principle dictates that there are certain limits on the sorts of questions we can ask the atomic world.
Oh, again, just more bullshit. There's limits to what we can visualize, what we can take a picture of. But there's no limit against what we can model. And the fact is I've modeled charge with just 2 kinds of force and 2 kinds of matter and 3 kinds of interactions. And they haven't come close. They invent crap like a gluon. Something that hits something and makes it move in the opposite direction.
And most crucially, while we now know so much more about what an atom is and how it behaves, we
Amazing.
have to give up any possibility of imagining what it looks like. Our human nature has forced us to ask questions of everything we see around us in the world. What we've discovered has been beyond our wildest imagination.
Yeah, your bullshit. You haven't discovered anything. All you've done is make a fool out of humans. Just demonstrated that most humans are still dupes. Fall for any kind of bullshit. So just tell them a wacky story and they'll buy it. Alright, so a couple more of these to come. Yeah, so nobody's obliging you to watch. But it does get more interesting. So, till the next time and such, and so forth and whatnot.